Alright, we are back making our compiler for our own programming language called Hydrogen. So to give a quick demonstration here, we have a simple program here. We have y equal to this, x equals, y is just kind of ignored to be honest. X equals 1, if 1 minus 1, which is 0, then, well, that's false, 0 is false, so it's going to exit with exit code 1. So if we go ahead and compile this into, we'll see here we have the assembly, and then we get the object file, which we can't open, and then the executable. We can then go ahead and run it, and then echo out the exit code, and we will see we get 1. If we go ahead and change the program to instead if y, which in this case will be non-zero, we can go ahead and compile it and run it. We get 69, which is what we expect. So that's our simple programming language so far. It's described using this grammar over here. So we are going to continue. But before we do that, it's been a little bit. So there are a couple pull requests, or a few. Now, I specifically did say on here, I'm not accepting pull requests. But people do it anyway. So I think I'm just going to take a look. By the way, no guarantee I'm ever going to look at them, or any guarantee that I'm going to actually even add it. In this case, this is doing Windows stuff, which I don't want to deal with right now. Thanks, but I don't want to deal with any other platform at the moment. Close. So... yeah, I just don't want, because right now this only works on Linux, so fix variable types into size t. That's good enough, whatever, that sounds fine, honestly. What is this, like squash and merge or something? What is going on with my mouse? I think my mouse is kind of dying. I might need to plug it in. So we'll go ahead and merge that in here, and then minor optimization for error. What do we got here under files changed? Just refactoring out error to some kind of command or function. I don't really care. It looks fine how it is now. And then this one I took a look at, and this is pretty interesting because this actually seems like kind of some quality changes. So I think I'm just going to merge it. I'm not even going to check it. Looks good. It looks good. I don't know if it functions good, but we'll see. Oh, can't I like create a commit? Can't I like have a comment as well as with the merge? Is that not something I could do? I don't know. I don't really. Whatever. Oh, I could have added one here, maybe. I don't know. It doesn't matter. I don't care. All right, let's go ahead and pull these changes and see if it broke anything. Let's just see what happens. So let's rebuild the compiler, and hopefully everything still functions correctly. We don't actually have any tests or anything, so we're just gonna kind of see what happens. All right, well, things still seem to work, but. I want to look through the source code because I want to start off with some refactoring right away because I'm currently using the new CLion Nova, which is basically JetBrains' new C++ IDE with better everything. So there's a lot more inspections that I saw just kind of poking around. So I kind of want to just see and fix some errors for things that or fixed warnings that might make sense. Like, for example, moving that to the inner scope probably makes sense. So we'll go ahead and do that. The arena allocator, yeah, there's nothing really here. I don't know why it needs to be final. There's some fancy stuff in here that I don't really typically use, but you know what? We'll do it. We'll go along with it. So like simple things like this can be made const, this can be used std ranges, and then I think what it's going to ask me if it can be used in an if init loop or something. Not if init loop, but move this in here. Maybe not. Huh. But I actually can. I can just do, as long as this equals the end. Oh no, we do need that. Okay, I see that. Okay, this can use the arrow. And then we constantly get IDE errors. That just happens because this is early access stuff on this IDE, so that's just how it is. Yeah, see, I could do something like that. So what I can actually do instead is take this whole thing and then just move it in here and just get rid of that. Yeah, that's fine. This can be made const. This can be made const. So we're just cleaning some stuff up, you know. It's kind of satisfying, to be honest. Yeah, we'll just let it initialize this stuff because this thing is just annoying me. Can be made const. Cool. Maybe in our language we'll do const by default, because I do think that makes a bit more sense. Add const, and what do we have here? It needs to be inline. Okay. And offset is always equal to 0. Well, that's just because that's how we call it. We'll call something else at some other point, so we won't deal with that. How is everything else looking? How is everything else looking? Under generation, it's analyzing. All right, I just restarted it because it wouldn't finish analyzing. But there are other things like, I actually didn't know this, that you don't need to put in inline inside of methods, even if it's in a header file. It's just kind of like an implicit thing, which is kind of interesting. Also, I don't need these else here, these else's, yeah. So we can get rid of those. Something like this can be made const. So there's little things here and there that pops up. We'll just go ahead and, whoa, what was that? Oh, it wants me to turn that into a structured binding. Type in value. I mean, sure, if it works, I'm fine with that. I don't know. I'm actually a huge fan of this kind of static analysis. Like, I think it results in overall better code. I don't know. I tend to like it. I use it a lot for my projects. Just anytime there's a warning, I either follow the warning or like take its suggestion or just explicitly ignore it if I have a good reason to. It just feels like there's always like someone just kind of watching out over me, just like letting me know, yo, you might want to fix this, there might be something wrong. Especially in C++, where there's a good chance that things just are wrong. What is going on over here? Gosh, look at all these IDE errors. This is kind of more than usual, I gotta be honest. What do we got in here? Some inlines we can take away. We can go ahead and do that. Alright, I think that's good enough. Let's just make sure this thing still builds. Yep, it builds. More IDE errors. Yeah, we're just gonna have to just get used to that. So let's do this. Actually, let's just try and do this all in one command. So we'll do this, and then we'll do /hydro. Oh no, not /out. And then we want to echo the output. Right. There we go. So it'll compile it and run it all at once. So if I go ahead and modify it, like change this to Y, I can just run that one command, and then there we go. So we didn't recompile the compiler, we just recompiled our application, our hydrogen file, right? So, and I know I need to make the font bigger for the people that are watching it on their tiny ass phones. Okay, okay, let's just go ahead and commit just some refactor, some stuff. Yeah. That looks good. We'll just go ahead and commit that. I don't know why it was showing 2 of everything. Yeah, I guess CLion's a little bit more broken than I thought it was. Did it not want to push it? Oh boy. Oh, why are there like 2 of them? Yeah, just do that one. Oh yeah, there are 2 of them. Yeah, I don't really know what happened, but I think we're all good now. Yeah, okay. I think we're okay. Whatever. Early access, whatever. It is what it is. Okay, so I think we're going to go ahead and do some comments because it kind of annoys me that I can't just have comments in here. So we're going to choose, what kind of symbol do we want for comments? Do we go with the good old Python is always right and you do a hashtag? No, just kidding. What do you think? Hashtag, get out of here. Do we go the assembly approach and just choose a double semicolon? No, we're not going to do that. We're not going to do that. How about a double dash? Isn't that something? Oh, I know. Isn't it? Oh my god, I don't even know if I remember. Is it this how you do a comment in HTML? Is that? It was something like this, right? Do you need like a slash in here or something? I don't even know. What if our comments are just like that? Yeah, no, I think we'll go with the good old double slash for a single line, and then this for a multi-line. All right, if I could type. I think that makes the most sense. Okay, what is my mouse doing? I think it's like out of battery, so I'm just gonna like plug it in to use it as a wired mouse because it seems to be having some issues. So we'll go ahead and plug her in, and here we go. Seems like it's working a little bit better. All right, so how do we do comments? So I think there's a couple ways we could do this. We could do this either in the tokenizer or the parser, but I think it makes the most sense to do it in the tokenizer because ideally you shouldn't be able to parse comments. Although there are languages that will execute certain things in comments and like treat them like as code, which is pretty nasty if you ask me. TypeScript. So, or like JSDoc or something. I don't know. Whatever that stuff. That whole world is its own thing. But I don't want to do any code as comments. Like if you write a comment, it is a comment. It will not be executed. I won't even let it past the lexer or the tokenizer, however you want to call it. So basically you cannot parse comments because after tokenization, they just don't exist, which is how it should be. So with that in mind, let's see how we can implement that in our code. So actually, we'll do some almost like test-driven development here. I'm just kidding, but kind of. We'll go ahead and add the comment first. We'll be like first because it's the first comment. Oh my gosh, I'm so funny. And then we can run it and then see it. We got invalid statement, right? So what we need to do is make this valid. So, or not a valid statement, but we need the application to be valid. So right now this, even though it says invalid statement, it's still compiled. Oh wait, it doesn't compile because it still executes this anyway. Wait. It says invalid statement, yet it still executes. Okay, whatever. We'll fix that later. So let's go to our tokenizer, and in here, so we're doing a peek. While peek has value, so we are, so we want to say if it's like a double slash, right? If we have two slashes in a row. So the way we can do that, doesn't really matter where we put it. We can just put it, I don't know, after this, sure. Else if we peek and it has a value, okay, we need to check if it has a value, so we're not at the end of the file. Or maybe we actually already do that. Yeah, while peek has value. So we're guaranteed to have at least one value. So if peek.value equals slash, and the next token also has to be a slash, which means there has to be a next token. So we can do peek, is it peek 1 or is it, how is this? So it's 0 by default. Okay, so well, and peek has value. So, and peek 1.value equals slash. So basically what this is looking for is if there is two slashes next to each other. I can already hear the comments yelling, I need to zoom in. All right, chill. Then what we want to do is we want to just keep going until until we encounter a new line. And then, yeah, we just want to keep consuming until we're at the end of the line. So how do we want to do this? So first we need to consume, can I consume two things? No. Okay, we'll just consume both. So we consumed both slashes, and now we need to do while peak.has, oh my gosh, I'm spelling the wrong peak, peak.has value, so while there are tokens, and peak.value doesn't equal a new line, then we just keep consuming. Otherwise, we consume the new line, and then we continue. Does this work? Now, something interesting, though. Okay, we are using just Linux/N. If we were using Windows CRLF here with the carriage return and then the new line, that wouldn't work, or classic Mac, if I don't even know if that's a thing. So we're just gonna pretend like it's just gonna stick with new line, and we'll deal with the consequences later. This doesn't even work on Windows yet. Again, I'm in WSL, so this is technically running in Ubuntu. So we'll just assume that it's all just gonna work. Okay, well, let's just actually see if this functions. All right. Okay, we got 69. All right. So I think that actually just worked first try. If I throw in an X here, oh wait, no, it was X minus 1, then it won't do it, yeah, okay, so that worked. And then so if I like comment out something, like I just comment this out, whoa, sexy, whoa, accidental typo, holy crap, then we should just exit with 0 because there's no explicit exit. Why can't I, what's going on? What the heck did I just do? Oh. Well. Out of range. Huh. Well, that's interesting. I want to see, can I debug this? Will this actually function if I debug it? Yeah, okay. So there seems to be an issue. Ah, okay, I see. I don't think we need this other consume, because I think if it's white space, yeah, is space, which I think also takes into account new lines, so I think we can just kind of ignore that, to be honest. There we go. Okay, so that works. Cool. So we got single line comments. So let's just go ahead. I want to commit more often because, okay, there is obviously an issue here. Things are duplicated. Well, that's really annoying. Okay, we'll just wait to commit. We'll deal with that later. Okay, so we got single line comments, which is cool. That was extremely simple. So now let's get multi-line comments. So let's just go ahead and do, I guess we could just do this, right? To test our multi-line comment. And then we can do like exit 420. Oh wait, that doesn't work because there's like we can't have that many for reasons. Okay, let's just choose like 4. All right, so that's our multi-line comment. So this should not work. Right, we get invalid statement. All right, so let's go ahead and deal with that. And then actually, we also need to update our grammar, I guess. Do we? I mean, yeah, I guess our grammar should. Yeah, it's not just a part. Well, I'll think about that later. Okay, so. Multi-line comments. All right, so we need to look for like this token and this token. Well, it's basically going to be the same thing that we had here, but we're just going to say if the value is a slash and then the next one is a star, then we consume both of those, and then while it has a value, and peak.value doesn't equal a dot, and peak1 dot has value, and peak 1 dot value doesn't equal the slash, then we consume, otherwise and then we consume. I think that'll do it. Maybe? I don't know. Oh, I think that actually worked. But there is a case, here where if we don't close the comment, this should crash. Yeah. So I think what I want to do is I'll just do if peak.hasValue. So I think I'll have that be valid. Like you can value. So I think I'll have that be a valid thing you can do, is just have an open comment like that and never close it. Yeah, so now that functions. So it just kind of like ignores everything after it. So then if I go ahead and do something like that, it will ignore that one. Or if I just do like a one there, we're good. So that means even if I do like other stuff in here, or like try and open up a new comment, like that won't do anything, right? Okay. Maybe not. Maybe we won't allow, what is the issue that is currently happening? We're getting an invalid statement, but I don't know why. We have a slash here. Wait, is it counting like this as the end of comment? Wait, that works, but this doesn't? What? What has gone wrong? I have a feeling that something is wrong here. So if we have a value, then consume, and then we'll say if this and this, then break, else consume. And we still get an invalid statement. So something has gone wrong here. If I just put in an L, that's still messed up. Okay, this is interesting. So, kind of curious here what it's consuming. Let's just do a little bit of print debugging. We're gonna print what we consume. All right, I kind of want to see what that looks like for our inline comment or multi-line comment, and it's not consuming anything. So if peak value is slash and peak1 has value and peak1 equals star, that should be but it's not. Why are we getting nothing here? Is it even entering this loop at all? Okay, it is. So let's do some real debugging, because I don't quite understand what's going on here. So we consume this and consume. Why does this... So does this just return false? Wait, did I miss something? Did that just return false? No, it went in here. Oh, no. We want to say if it does equal that, and... Oh, boy. I did an oopsie. Okay, I think I fixed it. Okay, But if I put in a double slash there, we're good. Okay, we are good. I made a Boolean logic error. Okay, so this seems to be working. So there we go. We just added comments. That was actually extremely easy. So I guess the thing is, do I add it as part of the? I mean, it probably should be part of the grammar, right? Yeah. The only reason I'm was even kind of waffling on this was that we're kind of using our grammar as like how we should structure like the nodes for our parser, right? Like when we go into our parser, we have all these nodes here and they correspond with the nodes in our grammar. But why can't I zoom into this? Whatever. But the comments don't get to the parser. But they're still part of a valid program. So I guess we'll just allow it to be like, so I guess a program can be a statement. So it's a list of statements. I guess it's just like a statement. We can call a comment just a statement, I guess. But wait, does it have to be though? Can we, because you can put multi-line comments. Well, they're not necessarily multi-line comments. Well, they can be, but you could probably do something like this, no? Oopsies. Ah, I'm in insert somehow. There we go. Okay. You could have something like that, right? That still works. So it's not just a statement. I guess the single line ones kind of are. But not really, because you can have them at the end like that. So, like, where do they even fit in the grammar, you know? Because you can just kind of put it anywhere, but they don't affect the actual parsing. So, you know what? Because I'm not sure where to put it right now, I'm just going to not put it in the grammar for now. And especially because you can just kind of put them anywhere, which makes it kind of difficult to squeeze it in anywhere. Yeah, I think they're special. I think comments are considered special because I'm declaring them as such. And so we're just not going to deal with it. In the grammar. So we're going to go ahead and add these comments and then only add one copy of these somehow. This somehow got messed up in CLion here. I'll have to investigate. Maybe I'll have to clone the repository again because things kind of broke. I guess just discard these changes. Yeah, we have like 2 different directories here. And I'm not sure why. So I don't know. I don't know what's going on. But this works. Cool. So another thing I think we can add today, maybe we'll just add one more thing for now, is an else on our if statement. So we have if, but we don't have else, right? At least I don't think so. We don't have an else in here, right? Yep, we do not. So our else can have something in here that will execute. So, I mean, right now how it works is pretty much anything that comes after this is part of the else. So maybe we have an else if. So something that I'm not 100% sure of is to even have an else if. See, I don't know if you know this, but at least in my like formal languages class for computer science, I take a formal languages class, which formal languages is talking about programming languages and how, more specifically on how you describe languages in terms of grammars and all that fun stuff. And then we got to the subject of like ambiguity and parsing. And one of the problems with one of the ambiguous parts of programming languages, or a lot of them, is which else, or what if statement does the else like connect to? So if you have like nested if else's, you could have some ambiguity, right? So because normally you don't actually need the curly braces, right? So you can go ahead and do like, you know, your printf, like if you were doing it in C, you could do something like this, right? Or you could have like another like nested if, we could probably make this, else, I don't know, lol, then print lol. And so you can have something like this, even though the formatting is terrible. But I guess the question is, which if statement does this else go to? Does it go to this one or does it go to this one? And I believe that in C, it will just go to the closest one, which is this one. But in either case, it's a little ambiguous. And it's ambiguous because of, you know, they don't require you to put in the curly braces. Because if you do, this really wouldn't be much of an issue. It'd be clear, right? Because now in this case, it's pretty obvious that this, it's now clear that this else goes with this if. Otherwise, before, it could have gone to either. Yeah, so if you want to look this up, it's called dangling else. The dangling else problem in programming of parser generators is, yeah, because the else is optional, so it makes it ambiguous. Right, so avoiding the ambiguity, requiring braces when, braces or parentheses, I guess, depending on how you want to do it. Yeah, so you can go ahead and read more about this issue. I guess I'll go ahead and put this in the description if you want to read more about it. So, anyways, now that I've made a mess here, well, I don't even, I guess in order to get rid of the ambiguity, I'd rather do actually an elif. Just like you would have in Python. Something like this, and then else. I don't know, does this get rid of the ambiguity? Does requiring curlies and using elif, is that enough to get rid of the ambiguity? I don't know, I'd have to think about it. I think so. I think so. Well, we'll just try. So we'll make this one 68, and then we'll make this one, well, I guess we don't really need an else here. Well, whatever, because, well, we'll go with this. This will be our like test case here. All right, so we'll have like an if, and then an elif, and then an else. All right, I think that's pretty reasonable. I'll see if it actually breaks, if it's still ambiguous or not. I'm not really sure. So right now this won't work, right? Because we have an invalid statement. So let's go to let's consult our grammar. And so we have an if, and then we have an expression, then we have the scope. And then what we also want is an optional, we want an optional like else if over here, or elif after this. So what we can do there is make a new thing after our scope here. We can go ahead and let's go ahead and create, let's call it elif, and we'll make that go to, so we're going to go ahead and do begin cases and end cases, because there are two things that can happen in here. you could have elif, then parenthesis, and then an expression, right? You can have the expression. So this is the same thing as an if. I need to make this text. And then I need to have a scope. But you can have an if statement without an elif in there. So that means that this elif can be non-existent. And I believe you can represent that using something like epsilon, which I don't think we've done yet. Epsilon. Okay, my mouse. Epsilon, meaning that this can have this value. So this node can have this value, or it could just be nothing. So then if I go to this if up here, I can have like an elif over here. And so that means that this elif can be empty. So this elif is essentially optional, right? And then we can do the same thing for an else, I think. You know what? But the thing is, you can have an else without an elif, which is also something I need to take into account. Huh. So maybe what I need, well, okay, let's just create the else node first, and then let's see what we can do here. So we'll have like an else, and we'll have it go to, and the else can also is essentially optional. So that means we'll go ahead and begin cases, end cases, and then we'll have a new line here, and we'll have an epsilon, and then we'll also have the else, and then we'll have an expression, and then we'll have a scope. All right, so that should take care of that. Okay, we need a new line after that. All right, so I guess the way we can represent this, also this else if, you can have any number of else ifs in there, right? So maybe what we can do is we can do elif, and then in here allow another elif. So this essentially allows you to chain them. But the elif can also just be an else. Now maybe that might not make sense right now. So I almost don't want to call it elif. Maybe I should call this like a general yeah, maybe I'll call it like an if predicate. Like it's what comes after the if. And so then we could do something like this. Did I just make a mistake? If predicate, paste that there. Yeah. Yeah, so something like that. So you have the if, and then, so you have your if, and then you can have a predicate to it, which is like the continuation of the if, which can be empty, because you can just have if with nothing else, or you can have an else if with, optionally, another predicate chained onto it, and so you can either end it with an else, or you don't have to, or you can have as many else ifs as you want, but eventually you get an else at the end. Okay, I think this actually does work. I think that will work. So I think we can go ahead and we can implement this now, right? We can do it. So So that means that we need to add a new node called if predicate. So let's move this over here. And let's go ahead and go to our parser. Well, also we need new tokens. Yeah, so maybe we should do that first. So let's add, so we have if, let's do elif, which is not reserved, and then we have else, which is reserved. So we'll do that. And my mouse continues to move because it's plugged in. I love wireless mice, but charging them is a pain, and I'm not buying one of those mouse pads that will charge it. So I'm kind of stuck having to plug it in and forgetting to plug it in. So we have these tokens. So we where's the actual tokenizer? Oh, okay, it's over here. So where is it where we compare keywords? Okay, here are our keywords. So we can do else if buffer equals, and then we'll do elif, oopsies, elif, then tokens dot push back dot type equals token type, and we will do, can I just do elif? Yeah, there we go, there it is. We can clear the buffer, and then we just do it one more time. Else tokens dot pushback dot type equals, maybe I can use in place back, I don't know. Again, I don't really care right now. Buff dot clear. And we get a nice IDE error. Everything's just blinking at me. Okay, so there's that. So now we have the keyword. So what happens if we just run the compiler? Actually, what is going to happen right now? We get invalid statement. Okay. So we also need to improve these error messages. They're so bad. Like, you thought C++ error messages were bad. Boy, imagine just getting invalid statement and no indication as to where the error happened. Because that's basically what's happening right now. So we need to go ahead and modify our statement here. So we have, where's our node scope? Node scope. I see the comments about node scope 360, which is kind of funny, I will say. Node scope 360. It's pretty good. All right, so we'll do node statement if predicate. Well, it's not a statement, is it? A node if predicate, right? And in here, we have the what do we need? Well, we need the expression, and then we need the, yeah, I'm just, if you're curious what I'm looking at, I'm just looking at this. Maybe I should have it open. Maybe I should do like this fancy, like keep on top of everything, right? So we have if predicate, expression, scope. So we need the scope then. Okay, wait, actually, the if predicate can be three things. Well, it can be two things or it could be nothing, which is three things. So that means that we need the one for node if predicate elif, and then we also need struct node if predicate else, and then we need the actual see, okay, I noticed that I probably shouldn't have done it this way, where like the statement contains a variant. I should just have the node statement be the variant. So I think I'll fix that later. Like what I'm saying here is I think I should just have using node statement equals like standard variant and then have it be equal to this instead of having a struct with a single value in it. But I'm going to keep it consistent for now and then fix it all at once later. So maybe I'll add a to-do for that so I don't forget. To do use using instead of struct. You know, maybe that's something I should do later. But again, for consistency right now, we'll go ahead and do it the same way we've been doing it, which is node if predicate, and then we'll have a variant in here, which is basically a sum type of node if predicate else elif, node if predicate else, and then we just call it bar, I think. So inside of our elif, the things we care about, what are we going to need? We're going to need the expression, right? So we're going to have a node expression, and then we care about the scope. So we'll go ahead and put in the scope here. And then we will need, and optionally need, an if predicate, right? So that means we could do an optional node if predicate, right? Predicate. And that means that I need to forward declare this. And because I have a pointer here, it doesn't need to be a complete type, which is good. All right, there you go. You're happy. All right. So now for our else, okay, I didn't finish this actually. Wait, I did finish it. We have else here. You know what? I don't think I need this else here. I think I could just take it and put it in. Put it in right here. Okay, I seem to have an issue here. I have extra text. Come on. Wait, else expression. Hold on, this isn't right. Else, I need a scope. Like this. Come on, stop doing that. Yeah, so I can just do that actually. Yeah. So that's actually what we should do. And so in this case, we just have a node scope, which is the scope. Right. All right. So that takes care of all of that. So I think this is all set up correctly. So now we need to deal with actually parsing it, which means we need to look for where we do our parse. So we go to parse statement, and we can look at what we have here. So what do we have? Where's the actual if? Okay, so we have the if here. So this is where we're parsing the if. So we try consume this. Okay. And then we get the scope. Right, so then we have the statement here. Statement if. Okay. But now what we need to do is we need to say that well, we need to go to our node statement if, and we need to add an optional node if predicate, like that, right? And so node statement if, wherever that's used, which is down here, we need to say that, how do I want to do this? Statement if dot the predicate equals try. Well, how do we? Well, all the parsing returns an optional, so we could just do parse. Oops, parse if predicate, and then we'll go ahead and create this, right? So we'll go ahead and do std optional node if predicate parse if predicate. Cool. So that's how we'll do that. So, oh, and I know the font's too small. Oh my gosh, it was small for a long time. Oh, you guys are gonna boil me. Not grill me, but boil me. I don't freaking know. Is this why people use tiling window managers? What? What? Really? What? Wait, you guys aren't using Windows with bloated IDEs? What? You're using... Wait, you're using tiling window manager on Linux? What? What? No, I don't do that over here. what am I doing again? Okay, so there are three things that can happen here. So I need to check if there's an elif. So if try consume, what is try consume? Okay, it's been too long. I don't even remember what this even does. So we try consume something. Okay, I need this to go away. So we try and consume, but we don't want to do that. Oh, this is a try consume that will give me an error message, but this will not give me an error message. Okay, oh, I see what I can do. Okay. So we could do an optional node if predicate elif. We could do like elif here equals try consume token type, so we can give it elif, and then it doesn't work because I screwed something up. What did I do? Oh wait, it's just a token. Oh yeah, that makes sense. What's the naming scheme I kind of have for this kind of stuff? Well, I don't actually need the token, so I can just straight up do this, actually. Right? Yeah, that actually works. So if try consume elif, then what I will do is then I expect an open parenthesis. So I'll do try consume token type open parenthesis, right? Otherwise, we will say expected this. And then we'll do, we need to get the, the expression? So I could do expression equals parse expression else expected expression, and then we can just exit failure. We need to go ahead and create the actual node if predicate elif. Right. Well, we need to allocate it. So we need to do, like, what is it? Allocator dot in place now it's called. So we could do node if predicate elif. Just like that. So we could say if predicate dot expression equals expression dot value. Just like that. And then what we can do, we need to try and consume the close parenthesis now. Expected close parenthesis. And then we need to get the scope. So we'll do if auto scope equals parse scope. So if we successfully parse it, then if predicate scope equals scope dot value. Else we have an error. Expected scope. Exit. We should probably take care of. We should abstract some of this out because it keeps repeating itself. But in order to find a good abstraction, I think you need to repeat yourself to discover the patterns before you try and create abstractions. In my opinion. So, okay, we got the scope. What else do we have? So we got the scope. Okay, then we have the predicate. So this is like, it can optionally like continue it with another else if. So we can do if predicate, hello? Am I like going crazy here? Why is it? Okay. If predicate dot. Why is this like... Why is it dying? Predicate equals... parse if predicate. Oh, so this... Yeah. So this is recursive, right? Because if you look at it, you have if predicate inside of if predicate here. So this becomes recursive, which makes sense, actually. What the heck is going wrong? Have I, like, screwed something up completely? I think CLion's just died again. I think I might need to restart it. Okay. I think that fixed it, just restarting. And that needs to be a pointer, right? Okay, so then that takes care of everything. So then I can go ahead and do auto... oh, see, this is Elif. So maybe I should call this Elif. And then do auto predicate equals allocator dot emplace. Wait, there's still a dot alloc, isn't there? Yeah, whatever. Node. What am I doing? If predicate, and then I can give it elif, and I can return the predicate, right? Yeah. Cool. So now I just need to do this again, but for the else. So I'll do like, well, because I returned there, I could just do an if. Try consume, and then what is it? Token type else. So we try and consume that. So if once we consume the else, we want to look for the scope. So I'm going to do if auto scope equals parse scope, like that. Else, we have an error. Expected scope. Exit failure. And then we'll go ahead and do scope dot. No, I need to create this. So auto else equals m allocator and place, or I guess it would be just alloc. I guess I don't really know which one to use. What does this do? So this just takes in the args and forwards it. And alloc doesn't take arguments. New? Now we have allocated memory. Interesting. Interesting. So maybe I don't need in place here. We could just do alloc for these. But if I want to pass in arguments, then I use in place. Right. If predicate else, I'll say else scope equals scope.value. And then we can go ahead and return, no. We want to do auto predicate equals allocator dot in place. Note if predicate else return predicate. Right. Add const there. And so then we just, there's not an error if we don't pass these two, because if it's not either of these, then we can just return nothing. And so we can make that explicit, right? Or is there like null option or something? No, I think that's fine. I think that's fine. You could do that. So, okay, so that should function. Obviously, we didn't modify the generator at all, but so we get 0. So I'm kind of curious, what's actually even happening? So so this is false, but it's not doing this next check. Yeah. So we need to go into our generator here. And we need to see where we generate the if statement. So we have gen if, right? Or gen statement. And then we have statement let, statement scope, statement if. Okay, so statement if. Right. So we need to say, so we generate the expression, we pop the value into racks, we create the label, we test it, and then we jump if it's 0, meaning if it's false, we jump to the label that's after here. Right. So then what we want to do, I guess, how do we want to do this? Because if we have an else if, sorry, my dog is making noises, but how do we want to do this? So I guess we'll need a label for every single else if. How do we want to do this? Well, okay. Well, let's just go ahead and create, let's just go ahead and create the function first, and let's just see what happens. So we'll just do void gen if predicate, and then we'll give it node if predicate, and we'll call it pred. So let's create the visitor first. So we'll just call predicate visitor, and we'll take in the generator, and then there can be two things that it can be, right? So it can have node if predicate elif here, or you can have node if predicate else. Okay, and then we need to go ahead and create it. How do I do that again? Whatever, we'll just copy and paste. So predicate visitor, and then predicate, there we go. Okay, so what we need to do, I guess, how do we want to structure this in assembly? I guess is a good question. So if I bring up like Notepad++ or something, just bring up Notepad. So we have some instructions. So we have the if statement, and so we check the expression. So you have like the expression, and then you do the test, and then after the test you test if it's 0, and you jump if it's 0 to like a label. We'll just call A. So if it's 0, it'll go to A, and that acts as our like else. And then we have like the scope, which is inside of the if, which is what would execute if it's true, right? So if it's not 0, meaning that it's true, then we execute the scope. And so what that means is that if we haven't, so this is what we have now, but if we have an else, let's just say we have an else and not an else if. If we have an else, well, let's do an else if. We then, after this jump, we also need to do the expression for our else if. We then need to test it, and then we need to jump to another label if it's not true, like down here. Right. But what we have to do is then, if we have an else if here, that means that after our scope, we actually need to jump all the way to B then. Right. We then need to jump all the way to B. So I think what we need to do here is take in another parameter after our else, or for our if predicate, that jumps that maybe jumps to that jumps to after this whole thing. Because if you have a bunch of else ifs here, if you have like a bunch of these, as soon as you get one that is true, you don't need to check any of the other else ifs or the elses. You need to jump all the way to the end. So I think what we need to take in is a label, which I think are just strings, right? We just have strings for labels, yeah. So let's take in a string that, and let's just do, let's call it like end label for now, and we'll say, and I completely put this on the wrong thing. Where is, needs to be over here. So what we need to do in here is pretty similar to what we did for the if. So I'm just going to copy this for now. So we'll do elif expression. Then we create the label. Yeah, we create the label, we test it, and then we jump if 0. And then we have elif the scope here, and then the label. And then you might have another one chained after it, right? And so if you have another one chained, I think what you just need to do is we can just call this again recursively. Gen if predicate. So we'll do if, well, if it exists. So if elif predicate dot has value, then we'll generate the predicate with the value. And then we'll give it, we'll just keep passing it the end label. And we need to do gen dot. And then this else. You know what? I don't think we need this end label. Oh no, we do. We need this end label because if, so we generate the scope, and then we need to jump out of here. Because as soon as one of the else ifs are true, we need to stop doing the rest of the else ifs and then jump to the end of the if statement. So then we could do, how do you just do a jump? You know, I honestly don't remember. x86, 64 jump instruction. Like, I just want just the jump. Jump, quick reference. All right, this isn't very quick, and it's not scary. Oh my God, my eyes. Okay. Jump before focus. Is there just a jump? Is it just J? What? Am I going crazy? Is it just JMP? Sure. I'm just going to go with it and hope that that's correct. JMP to, okay, I forgot. This is a stream. So we'll have to do this. And then we give it the label, end label. Like that. Right. So then in here, we need to do gen scope, else dot scope, and then I get, yeah, that's really all this is. This is confusing me. I hope this is gonna work. If gen, no, if statement if dot predicate has value, gen if predicate, statement if predicate dot value, and then we give it the label. All right, my level of confidence is not very high. Oh boy, it's already screaming at me. Oh no. Oh. Ooh, this is a problem. Yeah, I can't use it in here, which means I need like a... Seems like I need one of these in here. Can I make this const? Can I do that? And then I give it the end label. Do I need to like do this? Okay. So that gives me 0. So this is false. But this should be true. So I don't think it worked, is what I'm saying. Okay, So let's see what's going on here. So we have so let's see if we can find where even anything is happening. So we have label 0 here. So this is our first if statement. So we test and then we jump if it's 0 to label 0. Okay. I think I see what's going on. So I think previously what we did is we jumped if it was false. Otherwise we continued. But I think we want to continue if it's... we want to do this backwards. So instead of jump if 0, we want to jump if it's not 0. Which I think is JNZ. JNZ. So I think I need to like reverse that, right? Let's see. Let's see if that will do it. Where's the generator? Because if it doesn't, then we... Yeah, I think it needs to be... Yeah, I think this needs to be the opposite. Same thing up here. I think it's JNZ. Okay, now that gives me 69. Okay, so okay, so that actually is not true. What I'm expecting should be 68. Right? So what happened here? So if it's not 0, then we jump to label 0. Which is over here. But it is 0. Okay. Okay. I think I see, yeah, I'm just getting kind of flipped around here. I think what I need to do is put this up here. So jump if it's not 0 to the label. Okay. You know what? Okay. I think I need to structure this better. So we have, how do we want to do this? So we have our if in our expression. So we have our if expression, and then we test that, and then if that is true. If that is true, we just want to jump. So JNZ essentially says if it's not 0, so if it's not false, which is true, so if it's true, then go to like label A. And this is like where we have the if scope. All right, and then we need to have like an end label. We call it like end. We have the end label. And then if it's not, and then we can do if there's like an elif expression, we test it, and if it's not equal, or if this is true, jump if not equal to b, which is over here. Yeah. Okay. I think I see what's going on here. So what I need to do is I think I need to create another label on our if. So we have a statement if, and we have this label is, we need like a true label where we execute the true case. I mean, do we need that? Maybe we shouldn't have that. Maybe we shouldn't have a true case. This is confusing me. We test. We jump if it's 0 to like A. Maybe. We jump if 0 to A. That's how it works right now, I think. Let me see. Okay. What exactly is happening here? So jump if 0 to label 0, and then it goes all the way down to here. So if it's 0, then we want it to go to the label that's over here. Like that. Oh my gosh, my dog is making all kinds of noises. Yo, chill. Jeez. Okay. So, okay. So jump if 0, so if it's false, then go to here. And then what we need is like, if it has a value, then we need to create like an end label. End label equals gen create. I think I need to create another label, give it this one, and then m output end label. Okay. So now what we have here, we're still getting 0. So jump if not 0. So jump if it's true, then we're jumping to label 2, which is down there, which is not what we want. Okay, so we're in here. We're in our else if. We test it, and we create a label. If the else if is true, we want it to execute. We want it to execute. So then we do this. Okay, we got 67, which I still don't think is right. Okay. So this is false. So if I made this true, we get 69. Otherwise, if I make it false, it goes to 67. But this should still execute. So it's not doing the 68. All right, we're getting closer. So okay. We have this label here. So if it's false, hold on. So, okay. How's that if statement working again? So we have jump of 0, then we have the scope. Okay, so we want to do it like this. And then if it has a value, I want to have the label here. I think that's what we want. Maybe like this? Okay, we got 68. Those are both false at 67. If this is true, 68. And if this is true, we get 69. I'm so sorry that I wasn't really talking the whole time because I was getting a little confuzzled myself. So, okay, let's think about how this works. So, okay. We have our if. So we gen our gen statement. Okay, so what we do, where is our if? It's getting too late. All right, so we test the expression. So we execute the expression, we pop it in the value of the expression into Rax, and then we create a label. We create a label like in a variable here, but we don't actually put it in the assembly yet. And so then once we test the expression here, we jump. If it's false, we jump to another label after our scope. And this, so that means that this scope will only execute if this is not false, meaning that the expression has to be true. Cool. So then, after our label, if you have an else statement or either an else statement or an else if, doesn't matter, if it has a predicate, then what we need to do is we need to create another label that goes after all the else and else ifs, or after all the else ifs, because as soon as one of the else ifs is true, you need to jump after all the other else ifs to the end, right? So, like if you have, I mean, for example, I mean, you can even see it here. As soon as you, even if we didn't have an exit here, we have an exit here. Maybe we can actually test this better. We can have exit z, and we could set z equal to something. Oh, we don't have reassignment, do we? Oh no, I don't think we have reassignment. So we can't actually test that out yet. Yeah. Okay. I'll have to deal with that later. But even if we didn't have this exit here, once this executes, if this ends up being true, we need to skip after this else. So we have to have like a label that's after everything after this else, after this if, which is what that end label is. And so then we generate this. And so if it's an else if, we pretty much just do the same thing as an if. Yeah, this is actually pretty much the exact same, right? Otherwise, if it's just an else, it just has a scope to do, right? So that's yeah, it's confusing. I highly recommend you just look at the code. And honestly, I wouldn't be surprised if I screwed up somewhere, but I think as of now, it's fine. I also think it would be a good idea to maybe add some comments to our assembly. Like during our generation phase, like we can add comments to assembly, which I think is just a double, yeah, it's just a double semicolon. Oh no, it's actually also a single semicolon? I thought it was a double. Huh. Never mind. It's just a single semicolon. So maybe we can like generate comments in our assembly too, so that we can kind of see what's going on, like if it's an if statement or something, if it's an if. So yeah, that was confusing. It's been an hour and a half actually, so I think I'm gonna call it there. I think we made some decent progress, and maybe I'll make a video in less than 3 months from now. So I'm going to try and commit this now, choosing every other file because CLion has just died. Add Elif and Else. Cool. And get rid of all these. And then push. 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 Or it's everything's up to date. Is it up to date? All right, we're good. We're good. All right. I will see you guys later.